morning, good afternoon, good evening, happy time zone, wherever you are, whatever you do. We're back. We're back for another Tuesday installment on the 45 show. And today I am so fortunate to have Seth Juarez. And guess who didn't turn up this morning again? It's okay. Don't hold it. Don't hold the grants. JP is probably going to be joining us later on the show. But in the meantime, Seth is here to fill in for both of them. How are you doing, my friend?
Good. How are you, bud?
I am good. Your sound is crystal clear. I love it. You know, you got
Fantastic.
you got the equipment, man. That's it. You know, you invest a little bit.
Yeah, sometimes you got to invest just a little bit. And that's what I did because, we're at home. Might as well have something fun, to work on.
I know. I forgot what an office looks like these days. Like, I don't even. Will I recognize the campus if I were to drive by?
You know what? I actually told them, I'm like, hey, because they emailed me like, hey, so which office are you going to be in? And I'm like, just get rid of it. So I don't even have an office anymore.
I mean, do you feel that you can do the stuff that you do at home in the office? I think most of the stuff I do, I can't do in the office anyway, like streaming and events and stuff. So, do I need to go?
I mean, I'm doing the stuff that I usually do at work right now.
From the comfort of your office?
From the comfort of my office, yes.
With
yes,
snacks
absolutely.
and food and everything else you need right next to you.
I'm just saying, the only thing we do not have is that beverage place, that we have in our offices. I don't have that.
Yeah.
So,
free booze, as in free soft drinks. We don't have free
that's
booze.
right.
Yeah, no
That's
booze.
right.
No alcohol allowed on premises. Although
That is correct.
I do miss hanging out with you guys and going for coffees and having lunches and the cafeterias. That's the one element I miss.
That is the one thing that is kind of a bummer, that
Yes.
we don't get to do that. So.
But we're almost there. I don't think we're too far off from actually getting back into being able to enjoy that on our own terms.
Yeah, I hope so.
Yes.
I mean,
Yes.
we shall see.
So tell us a little bit about you because I know you from a long time ago, but many people may have not seen you, especially on our show since it's an identity show. So tell us a little bit about what you do and why you're here.
Yeah, you got it. My name is Seth Juarez. I lead advocacy efforts at Microsoft for artificial intelligence and machine learning. Our mission is to empower every developer and data scientist to be successful with AI on the cloud, and we do that by three things. We do three things. We create content, we refine our products, and we help grow community around them. And so I deal particularly with machine learning and AI. So that's what I do at Microsoft. You may have seen me on shows. Sometimes they let me do shows like in between stuff, which is really nice, and I really enjoy that.
And keynotes. Don't forget that you don't just do shows; you do keynotes as well.
Sometimes
Yeah.
I do keynotes, but the reality is my day job is making sure that our customers are successful with AI on the cloud. So that's my job.
Can we discuss the recent acquisition? What happened yesterday? Because that was big news, right? 20 billion, my friend.
Yeah, I don't know too much about it other than
Okay.
it's a health startup. Like I don't have that kind of visibility. I'm not that important.
You mean they didn't consult you before they went and bought that for 20 billion?
Absolutely not. So yeah, basically, it's a health startup that has a lot of AI stuff in it. And the thing about AI that's really good is that human doctors are absolutely amazing people. They can look at a set of data and diagnose things. But imagine having the assistive abilities of AI to help doctors make even more informed prognoses, or diagnoses around health. And so that's what my first impression was, but that's just my uneducated one. I still need to read up.
Yeah, I look forward to see what it is because that was the second biggest acquisition that we did in Microsoft, I think. So that's a lot of dough on medical and AI. I wonder if we can take information of the systems that they build with AI and cross-pollinate other parts of the industrial solutions that we're trying to build, because that'll be my thinking. But again, I'm not that clever and I'm not that big in the command chain to be able to make an educated decision.
And me
Or
even
yes.
less.
I so doubt that one, dude. You're the brains of stuff and learning about machine learning and how we can use it. I mean, I've used cognitive services before, which is a version of our machine learning that it is readily available to developers, right?
Correct.
Yes.
Correct. And I'm happy to. I wanted to go over because some people look at AI, specifically when they're talking about machine learning, they have a hard time distinguishing the difference between all three.
Yes.
So I thought I would maybe explain these things as I would from a programmer's perspective. Most people don't know I was a .NET dev for nigh a decade before I went to grad school and started doing research in machine learning. And so I look at this from the perspective of a developer. And when I look at it like that, all of a sudden, I think everything starts to make sense. So what I'm going to do is I did not bring slides because who cares about slides? I'm going to literally like go old school, like teacher mode.
I love it.
Yeah.
It's,
so
you'll see a slide-free zone here.
Yeah, I'm going to so you can see me drawing things, right? I hope.
I can see you, yeah. And I'm going to move you the big screen now. So
all right,
more
so let's
real
do
estate.
This. Let's do this. Let me go ahead and explain the whole like AI, machine learning, deep learning. So AI is actually a really big, let's just say AI is this bubble. And I probably shouldn't say bubble in tech terms because everyone's like, Seth just said AI
It's going to burst.
Yeah, no. Yeah, that's not what it is. So AI is actually quite a large field. It's been around since the 50s. And so it's when I say 50s, I mean 1950s, like in the last century.
Yeah.
My kids sometimes are like, "Hey, you guys were born in the 1900s." And I'm just like, "Shut your mouth. Shut your mouth." But this was 1950s, and these algorithms are actually quite old. And the way I like to think of these is I like to think of them as like glorified search.
Okay.
So, for example, think of like playing tic-tac-toe, and I'm gonna go to yellow here. So imagine playing a game of tic-tac-toe against a computer.
Yep.
Notice that there is a really fun way of making this work. So if I put an X, let's just say I put an X here, and now I have to make the computer decide. Well, think about the computer literally can just say, well, I can put an O 1, 2, 3, 4, 5, 6, 7, 8 different places. So 3, 4, 5, and then we'll go like that. And so imagine like if it's X here, it can put an O here. If it's X here, it can put an O here, and it can literally create a tree. And then once it does this tree, it says the computer can even think further and say, well, if I put an O there, then what they're going to do is they could potentially put an X here. And then notice that you're basically building this big tree.
Yep.
Right? And so all the computer needs to do is find the optimal path to not lose. Right.
Nice.
And the thing about this is tic-tac-toe is that it's so small that you can search the entire space in memory.
Wow.
Yeah. And so this algorithm, you may have heard of it. It's an adversarial search algorithm called Minimax.
Okay.
You can make it a little bit smarter by doing something called alpha beta pruning, right? For example. So games like chess, where the search space is much larger, it's still finite. Right. So that's a Minimax now. So there's other algorithms, for example, finding, like if you're in Waze, for example, it tells you sometimes, hey, turn and go this other way. That is another example of a search problem. Because if you think about it, and I'm gonna go to green here. If you think about it, finding a route from A to B really depends on, like, for example, what available paths there are. So let's just say there's all these nodes, right? So you have the opportunity to go through this path, right, like right here, or through this path over here, for example, right? But what Waze does is it looks at these edges and it assigns a weight to it because by the, let's just say, traffic.
Yes.
And so now basically all you have to do is find a path from one point to the other using a heuristic function, and that heuristic function takes into account the weight, meaning how much traffic there is, as well as the distance, etc. And this is called a heuristic function, and this algorithm is called A star. And it's another search algorithm. But this is what AI was in the olden days. It was glorified search. But then what happened is the search space got way too big.
Big, yes.
So, for example, if you're looking at a picture and you want to know what's in it, like the search space is far too large. Yes. And so this kind of approach started to fall over, and so that's when techniques came about, and these ones are called machine learning, right? Because now the search space is much bigger, and so you've got to find a way to divide the search space. And there's a ton of algorithms for this one. Like, for example, you probably heard of decision trees, which basically looks at a search space like this, and it divides it up like this, and then like this, and like this. And so if you're trying to figure out green dots versus red dots, that's how it divides the search space. So instead of having to find the path or search the entire set of things, machine learning is really good at dividing things. And if you look at this little thing that I just drew, it basically divides the space in half, and then it divides the space in half again. And then it just tells you what the answer is, right? And this is called a decision tree. There's other ways of dividing the space. So for example, let's do another one. Let's just say we want to divide white points from green points here. Another way to divide the space is with something called a line. Right? This is what's called a standard perceptron algorithm. There's a way to project this into a bigger space. That's called an SVM. And so now I'm starting to tell you about all the machine learning algorithms that divide the space.
Yes.
These machine learning algorithms are super good, but it turns out that there were a class of machine learning algorithms that happen to be very good at some of the more squishier spaces, like looking at a picture, understanding what someone is saying in audio, and these techniques are called deep learning, right? It's basically something called a neural network that's a machine learning plus plus. Now, to call it deep learning, only marketing knows how deep the neural network has to be. But that's how I think of the space, and it actually is super helpful to think about it like this, because then all of a sudden everything starts to make a lot more sense. So let me explain now machine learning briefly so that it makes sense, right?
Yeah.
And I can save these diagrams for later, y'all, if you want to keep them or whatever.
Yeah.
So basically what machine learning does, and here is, let's just put a question mark in here. Let's start with programming, regular programming, because I like to think of stuff from a point of view of programming. So basically what we usually do is we have some I don't know. We have some input, right? We give it another value. We give it another. Let's see. So I'm trying to remember. So because I always get these mixed up, and then comes the output. Output, right? And then in here we have an algorithm, right? So we have the input here. And then we have the input here. Oh, I know what I did. Okay. I know.
While you're doing, our BSD guy is asking, can we NFT those images?
Absolutely. I will sell them readily. So regular programming has this thing called input and output, right?
Yes.
And in here we create an algorithm. All right. So this is what we usually do. And what we have to do is we have to come up with a series of steps to solve stuff. Right? But what machine learning does, and this is the crazy bit, is machine learning changes everything. ML, right? What we do is we give it the input and the output, and then what it produces is an algorithm for us. And then in here is the magic. Now this, I'm so bad at handwriting.
It can do that for us?
Yeah, so I'm going to draw this again because it seems to be quite surprising when I'm telling you. So let me move this up here. And now let me draw it again. So Emma, because I want, this is the important thing that everyone needs to understand. So now what we do is, here is the input. We give it also the output, and what comes out is an algorithm, and then magic happens in there. So this is the question, like, how does it actually do this? And what I did is I actually beforehand showed you kind of how it does it over here. Right? And so this is the magic here with machine learning, is you have to pick first a shape of what the algorithm looks like. And now these things have different names in machine learning land, right? These are called the features.
Okay.
No, I got it backwards. So the thing that goes in, these are called the machine learning features.
Okay.
And this is called the label, which is the right label. And this here is usually called a model, machine learning model. So when you hear machine,
I heard of models. Good.
So usually when you hear about machine learning model, literally it's basically a different way of creating an algorithm.
Right.
So let me show you this in practice. So let's go to this goodness here. So here's something called computer vision. You've probably heard about it.
Yes.
Let me go to my tweets here, Twitter.
Uh-huh.
And let me get my picture. I'm gonna get my picture out, and I'm gonna have it look at my picture. So there's my picture. Open image in new tab. So
It's a
let's
happy
get
picture.
This. Yes, a happy picture. Me and my lovely bride. So I am going to just do an analyze image on this picture.
Mm-hmm.
So now I'm gonna hit submit.
Okay.
So basically, there's like, I don't know how many models doing a bunch of stuff down there. One of the models is finding a bounding box. Another model is telling me what's in that bounding box. You can see over here the output of the models, and you can see, for example, it knows it's a person. Oops. It knows it's a person. You can see that right here. It has a confidence of 99. It also knows that it's an outdoor thing. There's some smiles. There's a human face. There is a woman. There is someone posing with a suit, right? So notice it finds out a bunch of things, but then it does other things.
Right.
And this is the crazy bit. It also gives us a sentence of what it thinks. And right now it thinks it's Seth Juarez et al. Posing for a camera. Now you're probably wondering, how does it know that it's me? This is the funny part.
Deep learning.
So back in the day, this is like 4 years ago, I was giving a talk with, I had a demo in a talk with Harry Shum.
Mm-hmm.
He used to run all of Microsoft Research.
Yes.
He's moved on to something else. And it was such a funny demo because I had a picture of him and and it would show both of us. It would be like Harry Shum and some guy, right? And I made the joke that I'm just not famous enough to be able for it to know me. And the developers must have watched this because, they watch stuff when programmers watch stuff when you show off their stuff, and they're like, we'll show him.
Yes.
We'll put him in. And so now it knows me. But this is a model. Now, what if you want to look at it in a little bit more like, let's look at it more in a more detailed way. So here's another model. This is something called custom vision. And here what I'm doing is I'm trying to get the computer to recognize whether I'm doing rock, paper, or scissors. But let me show you this model in action, because I think and let me see if I can get this other camera to work. So let me do this. This is all happening live. I wasn't necessarily going to show this, but I think it's actually powerful to show it. So CD vision. I think this is the right thing. So let's go to CD API here. API. Okay, let's take a look at this. And I always forget how to run these things. So let's look at the package oh, not the lock. Gosh dang it. Package.json. Looks like we want to do npm start. So we'll quit that. Quit, and then we'll do npm start here. I keep hitting the caps lock. npm start. So this is the back end of a program I wrote, and now let's get the front end going. So we'll say cd vision, and then client, and then this one also obviously has its own package.json. So we got to see how to run this one. Package.json. Looks like this is going to be. Hold on. Looks like it's yarn, so we're going to use yarn. Package. So
many tools.
Yarn serve. Okay.
Yes.
So there you go. So let's see if the API is. Oh no.
I know camera is broken, but it will come back. It does it sometimes.
So this is for some reason sometimes breaks. If your Azure Functions ever break like this is Azure Functions, by the way. Let me get a little hot tip here. So we'll go to where these extension bundles are, and you know what I'm gonna do? I'm just gonna delete it.
Oh.
Don't tell anybody, because it broke. So I'll start it again, and then you'll see that it'll be like, okay, let's do this. By the way, the front end is already working. You can see that's going on.
Very
you can
nice.
see that. There you go. You see now it's happy. Fixed it. Look at this.
Look at that.
And so now I have a front end and a back end. Let me go ahead and open this goodness. Localhost 8080. Localhost 8080. And what I'm doing is I'm trying to show you a machine learning model.
Okay.
So it's the rock, paper, scissors model. Let's wait for the cameras to... Oh, come on. It's not going to see any of my... I know what. It's not going to see my cameras because I'm using a corporate profile. You can see that there. So so it broke again, but that's okay. We're going to open a new browser without the
corporate profile. Yes.
And now you'll be able to look at us fixing stuff as we go. You're probably wondering why it's not seeing anything. It's because this camera is already being used.
Yes.
Thank goodness I have another one.
You came prepared here, man. Double cameras for backup.
So here's the other camera.
Nice.
And notice that in theory, if I put rock up, it does it. If I put paper up, and if I put scissors, you see that? But it looks like it's making some mistakes here with the scissors.
Yes.
So let's do this. Let's get some scissors here. So it's confused about this one. So I'll give it some scissors so it knows that. Let's give it where it thinks it's paper. And then I'll stop.
Okay.
And let's submit some more training data. And what you're going to see is I'm going to give it some more training data. So I'm going to submit the data, and you're going to see Azure functions. Kapow, kapow, kapow.
You can do that on the fly?
Yeah. So now I'm training. So now I gave it some pictures.
Yes.
And if I go back to custom vision, you're going to see if I hit refresh that now I've given it some more. Like this one is wrong.
Yeah.
Wait, what shirt am I wearing? I'm trying to see. I'm trying to make sure that it has the new one. Because there's got to be like, there you go. So there's Seth with the black shirt.
Yes.
Giving it some more scissors. And now remember when we looked at this, there is a machine learning model that is being produced, but basically you have to give it the features.
Yes.
Which is my pictures, and the label, which is I'm saying that these are scissors.
Yes.
And now basically I just have to train it. And training is going to produce the model that we want. So I'm going to do a quick training. This training takes about, I don't know, 5 to whatever amount of minutes. So while it's training, what I'm going to do is I'm going to show you the last model. And right now you're like, hey, it's saying that it's 100% accurate, even though, like, it's not getting this. But here's the thing. It's actually 100% accurate with the data that I gave it.
Right.
So when you train these things, you basically train it on 80% of the data and test on maybe 20% of the data. And so that's what this is doing. So that's why it says it's 100% accurate. So let me show you what's actually in the model. So with Azure Custom Vision, you can actually download the model. So I'm going to do an export. Nice. I'm going to do an export on this model, and we're going to look inside it.
You can also download different types of exports, right? So you can do TensorFlow, you can do mobile stuff, if I remember correctly. So lots of options there.
Correcto. That was a little Spanish for all y'all wondering. So this is what's actually inside of the model. This. Okay. So what I'm going to do is I'm going to literally, let's do this. Let me just literally put it out here so we can all take a look at what's inside, okay? Okay, so for some reason, it put it on my other desktop because, of course, why wouldn't it? What I'm going to do is I am going to put this into a folder called our model, and let's just put everything in there. And let's just Visual Studio Code the heck out of this and see what's in there, because I want people to know what's in there. So the first thing is, remember we talked about labels?
Yes.
That's the answer. Those are the 3 labels. I'm either doing nothing, paper, rock, or scissors.
Sweet.
The export manifest tells us what kind of model it is. It tells us the model file name. It tells us the label name. It tells us the properties, the SHA, etc. It's a classification. And then you're looking at the properties, and you can see, if you're a programmer, basically this tells you how you have to pre-process the image before you put it into the model, because it turns out that this function has an input shape as well as an output shape. Because remember, I said the model is a function.
Yes.
Now, here's the license, and this is the scary part. Microsoft's license is actually quite permissive. What?
MIT.
Yeah, so basically you can use this, download a model, and then use this inside of an application such as this one. And again, this model is running directly in the browser.
Whoa, nice.
Now it thinks I'm doing it. But because it has never seen me in this position before, it's starting to make mistakes. And so we just got to keep training it.
Sure.
Okay, so let's actually look at what's in the model. So let's go over here to the model folder, and notice that when I have models, it has like a program that it can open it with.
Okay.
So we're going to look directly inside this model. Here it comes.
Wow.
And this is it. It's not like everyone's thinking like there'd be butterflies in here or rainbows. Now you're seeing why this is deep
like a
learning.
workflow chart?
No, and it kind of is like basically a graph of computations.
Right.
So you can see that what it expects is and none means n number of images in the form of a vector of size 3 in the first dimension, size 224 in the second dimension, and size 224
So your function actually converts to this size before it passes it back to the model, so you can do the analysis?
You have to convert it to this size. And you're probably wondering, well, how do I know that? Well, it turns out that this manifest file told us. It says it has to be 224 by 224 byte. And then you can see that how it normalizes stuff, etc. So it tells you how to do all this stuff. And the cool thing is that if you're wondering, well, I don't know what this means. Well, this none here, think of it as like a picture. So I zoomed in too much. So let me zoom in here. Okay, so that's a good zoom.
That's a good zoom.
So here, just think of this as one picture. So it says none because you can actually pass it like any number of pictures. Think of this part as the channels in an image. And what are the channels? Where they happen to be R, G, and B. Right? So it's red, green, and blue. And this would be the height, and this would be the width of a picture. So basically what you have to do is you have to take a picture, and if you think of a picture, an image is basically a square, and in each pixel. There's 3 numbers.
Yes.
RGB. And you're like, oh, yeah. It turns out that this represents a matrix form of this picture. That's it. And you're probably wondering, well, what does it do? Well, it does a lot of stuff. It does what's called a batch normalization. It does what's called a convolution. It runs a function called a ReLU, which is a rectified linear unit. It does some pooling to downsize. Then it does 2 things at once. And so basically it does all of this math on the picture. Math until all the way at the end. I'll tell you what this one does. This does what's called a gem operation, which is a generic matrix multiply. And notice that it basically multiplies by a matrix of size 4 by 1024. And then the last output is of size 4. And so basically the output is a vector of size 4, and you're probably, well, what the heck does this represent? So basically these are like buckets of numbers, and wherever the bucket has the highest number, that's the output. And we're wondering, well, what does that mean? Well, it turns out that the labels are ordered so that this means none, this means rock, this means paper, and this means scissors.
So if you had 5 labels, it would be a vector
of size 5. Yes. See? And so basically when the output comes out, notice that it's doing like this thing called an argmax, which is basically looking at this vector of size 4, and it's returning the index of the one with the highest number.
I see.
And then it outputs the class label based upon the index found in here.
Right.
So it looks like 0 is none.
Yep.
1 would be paper. Do you see? And so that's what that is doing. And so now this iteration is done. I can do what's called an export. So I want to export to TensorFlow JS because nothing is real in computer science until there's a JS version of it.
Everything that can be written in JavaScript will be written in JavaScript one day.
I'm just saying, right? So now we'll export this. We'll download it. So there it is. We'll open this beautiful thing, and now we'll go back to Visual Studio Code, and because remember we're in the Vision project, so we'll just do cd Vision here. Boom. We'll do code dot, and now what we can do is we can basically replace this model. Here's the client
with the new one.
Here's the model. So we'll just do reveal in File Explorer. Here's the model. What we're going to do is we're just going to replace this. Delete.
Dump and replace, right?
with this. Oh, hold on, I gotta find the right. There it is. With this.
Okay.
So I'm gonna move this over. There it is. And now basically, if I refresh, notice that the model. By the way, I need to refresh again. Notice that the model now is from today.
Yes.
And I can go to the HD Pro webcam, and in theory, notice that now it oh well, it still has some issues. I need to give more example, but now it noticed it. Remember the scissors it didn't get?
Yes.
Now it gets this scissors because I trained it, but it looks like I need to train it some more and give it more pictures. Right?
More data. The more data, the more accurate the model, right?
There you go. And so now
is there a point that no matter how much data more you feed, the data will not get more accurate?
No. But we do run into a problem. So now let's talk about the ethics of this stuff. Because now we've seen okay, there is this process that you're starting to all recognize where we actually have to. Oh, I got to turn this on again. My little drawing thing turns off to save power. Isn't that clever?
Very clever.
Okay.
Some machine learning happening in there.
Or just power consumption, or just the. Let's not use machine learning for what a standard lookup table can do.
Fine.
Yes.
It's just a hash table.
Here I know. So here's the process. We have to always start with data.
Okay.
We have to also have a question. Like, what are we trying to answer? For us, is this picture have rock, paper, scissors?
Yep.
Once we've defined that question, then what we need to do is we need to take that data and run on a machine learning model. So this is my fancy picture for machine learning. Make a machine learning model. Then we see how good it is. And if it's good, we deploy.
Yep.
Just like I did. And so now it's on a website. But then this cycle happens, so because it's going to make a mistake, then what we're going to find is there going to be some errors, so we have to give it more data.
Yep.
Make sure the question is still valid, and then we make another model. This process of doing this automatically is called ML Ops.
Oh.
Yes.
Nice.
And now we're starting to get into developer territory because we want to have an automated way of building these models. But here are questions that we need to ask ourselves, and these are the ethics of it.
Yes.
I'll give you an example. This model works only with me.
Yes.
Why is that? Because I only gave it pictures of me.
Yes.
Which is not good.
No
so if
diversity.
you're trying to build a general purpose machine learning model, and you have, say, for me it would be white people because I'm Hispanic, it's not going to work.
Yep.
And if you go to the training images, you'll see it's going to look for this kind of color of fingers.
Yes.
Now, let's just say you don't have a data set with African Americans or people that are not of color. And let's just say, because it's all Hispanic me,
Yep.
your thing is not going to work. And you can have things like harms of quality of service, which means that the service is bad for someone that's playing rock, paper, scissors. That's not me.
Yes.
Or you can have harms of allocation, which means, like, let's just say you're building a machine learning model for recidivism, which is, does someone go back to jail?
Yep.
It turns out that the data that we have on recidivism is very biased because some people use data sets like, is a relative also in prison? And unfortunately in the United States, we have a disproportionate, when we look at statistics, incarceration rate for certain subpopulations, which means your machine learning model is going to learn that those subpopulations are recidivist, which is not good. And so that's a problem. And so this is a huge problem with machine learning models, which makes it even more important to be more fine-grained when we do stuff, which then takes me to the last thing I want to talk about, which is something called Azure Machine Learning. Because in Azure Machine Learning, and now we're going to do a sentiment model because I want to switch to NLP.
Nice.
You can actually run your own artisanal models and explore how fair they are.
Wow.
So, for example, here's one for. Let's go to a loan here. Here is a loan decision model.
Okay.
Where we can actually do explanations over a subgroup of people to see whether or not they will get a loan. So you can see, like, for example, a data explorer. You can see, let's do individual data points. You can see where the people are, and then you can create cohorts over like male, female, whatever, to see whether these things are fair. So here's another fairness, a fairness, and it's taking a little bit to load. Notice that we can look at the fairness of a model based upon gender and the accuracy, and you can see that here is a grid of all the models we've built, and you can see that the difference in parity difference, you can see the different ones, you can see the accuracy of the models, and you can see that the models, depending on the accuracy, you can have very different models for accuracy based upon demographic difference. And so you can do a lot of this cool stuff. But let's get into the specifics of building a machine learning model. So let's just say you don't want to use custom vision and you want to build your own model.
Because you can do it so much better, right?
Well, you can. It turns out that here's the funny thing. It turns out because I've seen this, I actually know this is a ResNet 18. It looks like to me, and so I already know how to build this.
Wow!
Just by looking at this, you get a sense of the shape, and
it's like the matrix. You can see behind the numbers.
Well, I mean, when you write code, all of a sudden you're starting to recognize like a for loop in here, right? You see this is the same thing twice.
Yep.
Right, and then there 3 times, right, and so you'll start to see patterns. I think it's a ResNet, but I'll have to ask them. So
I have a question from Telmix. How do you, going back to the ethics, how do you teach your machine learning to account for those biases from the stats and not be biased itself?
You can't. So you basically have to build a model that is less accurate to be able to compensate for the unfairness. And that's what those fairness tools are. Because it turns out, my wonderful friends, humans are just biased. And so if we are going to think that because humans aren't biased, and if you're like, oh, Seth just called me a biased person. Yeah, it's just that it's like it's built into our biology.
Yeah.
We have unconscious bias. If you see something that you're not familiar with, our threat receptors in the back of the brain, that's the animal part, let's say, fire off, and it's just a biological response. It's not anything to be ashamed of. I mean, you should be ashamed of it if you're using to discriminate, and you should be able to turn that off. But if we are to expect that people who are biased as a population, that our data somehow isn't, it's just not the case.
Yes. Yeah.
And that's where the problem is. So that was a really good question. So let me go over here to, let me show you a machine learning model that we built. Notice, and this is all in the cloud now. And I'm not even using anything in my
in your local machine.
In my So here is a notebook. If you've ever heard of notebooks, notebooks are really cool for testing things out. So notice here, I'm basically running a machine learning thing, and this takes 45 minutes to run. So I'm not going to show it to you. But basically, what this does is it helps me create a something that will convert someone's review into a score between 1 and 5.
Okay.
So it's like a review, right?
Yep.
And so you're noticing that I'm running this training thing in a pipeline called NLP sentiment reviews, and the training you can see is basically something we wrote in PyTorch. This was Cassie, one of my colleagues, wrote this in PyTorch. You notice that it's basically a text sentiment analysis. It uses what's called a text embedding that converts text into a vector, and then it has a linear thing, a linear output model that outputs the number between 1 and the vector. Oh, let me go here. And this you'll appreciate because we learned this before. It'll output a vector of size 5 because those are the 5 ratings, right? 1, 2, 3, 4, 5.
Ah, yes.
Right? And,
now I know
so
what I'm talking about.
The number of class. And the embedding dimension basically is we go from text to this embedding bag, which creates a huge vector, and then it converts it, and then from the embedding dimension we go to the class. And you can see that basically we're just running this experiment, right? And this is all PyTorch. PyTorch is fantastic. And so let me show you the output of that experiment. So let's go to NLP Sentiments Review Training. And you can see that we tried a number of different things to see if this would work.
Yep.
You can see here, let's see if I can go to the tags here. Well, I'd have to go inside, and I don't want to do that. So you notice that we ran this 1, 2, 3, 4 a couple of times. These are the successful runs. So let's let me select all of them so we can see all the charts. You can see how all of these models did, and this is the accuracy of the models. You can see that went up. You can see the accuracy of the validation data set. They all went up. Notice that some models just did not do as well, so we don't want to keep these. We want to keep these ones up top. And then you can see also that the loss function measures how bad we are at stuff. You can see that it goes down. You can see here it struggled and then it went down. But this one all the way at the bottom, run 62, was our best one. And so if I go to run 62, you can see the actual run that we did, right? You can see that we and this is all just regular code. The difference is that Cassie and I worked on this together. We were able to see everything together. We were able to run it on a powerful machine together, right? And that's the cool thing about it. So now, if we go to the outputs, you'll see in the outputs there's these model files. This is the actual model. So you can see here's some metadata, like the vocabulary size, the embedding dimension, the number of classes. This you're not going to be able to see because it's too big. You're going to be able to see the vocabulary data. I don't know if it'll load it because it's a lot.
Too
it basically,
big, yep.
Yeah, it's too big. And let's hopefully, I already did this one. This one you're not going to be able to see. And this is the actual model file. And we use these files to basically, and by the way, we always keep a snapshot of everything you run. Okay. So for example, anytime you want to run this model, this is how you run it. You load, you load the model, right? You load the path and the vocabulary data, and then you just run it. So the cool thing about this in Azure Machine Learning Studio s is you're able to save these models. And so, for example, here's our tacos review model, number 21, right? Because we build it, well, we have a taco shop. And you can see that this particular model has been saved. It's been versioned. You can see the artifacts inside there. And so now you have this whole entire place where you can do this end-to-end, remember, ML ops thing. And that's what's really cool about this. And later you can actually deploy this endpoint. And I think this endpoint, I don't know if we deployed this one, but let's go to Tacos review model. Let's see here. We run a lot of experiments all the time.
I can see that.
So let me just go to the endpoints here, and you'll see there is a Tacos review service. Yep. Let's see, which one did we deployed this one last? This was Cassie deployed this. By the way, notice that we name our computes like something really cool. So for example, we have all sorts of computers here.
Oh, look at that.
Yeah. So notice this is Cassie's computer that she works on, her notebook computer. This is my notebook computer. And notice I could be doing this all from like a Surface Go.
Oh, really?
Yeah, because this is just a web browser, right?
Oh, right. So the computer is actually on the cloud. You have a dump terminal more or less into.
Yeah, and here's our these are our compute clusters for running big jobs.
Right.
It's an NC12, which is a big machine. And the cool thing about this machine is that it will scale from 1 to 5 machines if it needs to. And when I ran the sentiment review, it had to run all 5 machines. And instead of taking 40 minutes times 5, it took 40 minutes because it was on 5 machines. Which was really cool. And now let's get to the last part of the compute, which I want to show you, is this notion of inference clusters. And inference clusters are clusters for running like the model. And this is Sauron. And so if I go to my endpoints here, let's go to my tacos review service. And let me copy that. And I don't remember how to run this, to be honest. So let's go back to
We'll come to you. I'm pretty sure we'll come to you.
No, we'll just look it up. Why don't we just look it up, right? I mean, that's what this is for. Okay. So I'll go back and I go to the score, and it looks like it's expecting, a text query. So I'll go over here, and then I'll say text equal. There you go. This is a crappy restaurant.
Oh, look at that.
And I hate it. And notice that it would rate this. Remember, here's the vector.
Yeah.
This represents 1, 2, 3, 4, 5.
Gave it 1,
2, 3, 4, 5, and the rating is 1, which means I hate it.
Yeah.
Do you see that?
Yes.
Now let's do that. Let's do another one.
There's no minus here, right? You can't hit it.
Remember, it's a score between 1 and 5 because we basically trained it on the on the Yelp review data,
Oh, okay.
right? And it always scores from 1 to 5. I love this restaurant so much. Boop. What's the rating? 5, because it's a good rating. Now let's do something that's kind of in the middle.
We're going back. You're gonna say average? This was average. It was okay.
Was all okay.
I'm curious to see if it's gonna give a 4 or a 2 or a 3.
It was a rating of 3, which
Nice.
is right in the middle, right?
Right
And
in the
so
middle.
what you're seeing is that this machine learning model that we built, it's all custom built,
Yes.
but it's all inside of this studio, which was
it.
super cool.
So,
And now
so
finally,
I have a couple questions.
Let's do it.
We have questions from the audience. The first one is, how much did it cost to run those gargantuan compute devices in the back end?
that's a really good question. So let's look at NC12.
For 40 minutes, right? Because it's
Azure
a compute that
40
you
minutes.
spin up for 40 minutes.
Let's
Say
see.
an hour.
NC series.
Yes.
So the standard NC12, where's the cost? I'm trying
It's
to
you
find
need to go to the costs, like a cost calculator, isn't it?
cost calculator.
Azure.
Beep, boop, beep, boop, beep, boop, beep, beep, beep. Beep, 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 beep. Okay. So we want a virtual machine. Beep, boop, beep, boop, beep, beep, beep. View.
I love the loading calculator there.
No, it's not what I want.
Yeah, there's a Phil Snubble. There's a pricing calculator for everything that you need to use on Azure, and you can actually create a combined view of multiple resources, so you can see if you're using storage and VMs and other resources, how much they will cost together for the month, and then you can adjust it.
Okay.
You can be clever with it. Oh, you didn't find the pricing?
I just wanted the NC series like VM pricing.
Okay.
I don't.
Can you use spot instances for these things, or do you have to have reserved?
So
compute?
the reason I want to show you is that this VM is expensive. It's like maybe like a $1 or so an hour. I think I don't remember, but
just
we'll
$1
find,
an hour?
But it adds up. Like it,
Yes.
like I don't know if it's $1 an hour, but I'm trying to find the NC series cost here. So we want NC12s, which is this one. Size, blah 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 blah. I can't. I want to find it. Let's do pricing. Windows virtual machine. It's not Windows though. It's a Linux machine.
There you go.
So let's go to payment options. Okay, so notice this is like 0.0111 an hour, and what we want is we don't want general purpose. We want the
dedicated one for
NCs.
yes.
Control F, NC 12. There we go. So this let's just use this. So it's $1. $1. This is 1 year reserved. 3 year reserved. Spot instance is okay, $1.80 an hour. So $2. So $2. Now, you're probably wondering, well, crap, Seth, you ran 5 machines for an hour.
Yes.
So now it's $10.
$10.
And you're probably wondering, well, Seth, you probably keep it on all the time. Yeah, I do. But here's a cool thing about this. If I go to my compute cluster, I can change let me go to the resource properties here and edit them. I can actually change the minimum number of nodes to 0. And if it's idle for 5 minutes, the machine will shut down.
Okay, so you're only paying for storage. You're not paying for the actual licensing or the compute. Nice.
Right? And so maximum, yeah, I mean, you're paying for storage a month, which is pennies, a month. And for the compute, when you run, also I'm paying for these machines because I keep these on because I like them. This is an NC6, but you can turn these off, right? You can see they're stopped.
And I suspect there is some policy or some automation that we can help with minimizing costs. So you don't forget, like you run 5 VMs, you forget about it, you walk out, and then you come back a week later from your holiday, and your boss goes, Says we need to have a conversation.
So just to answer your question directly, $10 to run that, and then if you're keeping the inference clusters on, you got to pay for that, of course.
Yes.
But you can download the model, right? Remember the model I was running here?
Yeah.
It was running all in my browser.
Yeah.
So that brings us to the next thing, which is why we're actually here.
Okay.
Because this is the identity show, and if we want to control this stuff. And you kind of like did a super nice segue. This is my access control. Robots, by the way, is where I keep all of my. This is all the stuff that runs Azure Machine Learning. So, for example, this right here, and this is what constitutes the base service. You have so you can see there's a storage, there's an insights, and there's the actual thing. These are extra stuff that I built, like Sauron. I built as my serving cluster. You can have your own serving cluster, but let's just say you want to control what people can do inside of here. You don't want data scientists like starting up machines that you didn't let them start up. So there is a way to create, no, that's not what I wanted. There is a way, if we go to IAM, access control, there's a way to create these things called custom roles to control what people do inside of these Azure Machine Learning workspace. So let's add one. And let me just we'll call it something that I can remember. And let's just go over here and look at the permissions. And we'll go to machine learning here. Notice I've done this before. And you can see that here are all the permissions that we can add. I did add permissions, but you can do exclude permissions. So for example, compute, let's hit that. Notice you can actually decide who can create or update compute resources inside of the workspace.
Very nice.
Right? You can say who can start it and who can stop it. Who can do you see what I'm saying? And so if you're worried about cost, you can create special policies for Azure Machine Learning service to not do things. Because what you want is you want your data scientists to live in here. They don't want to live in here. They live in here. And so basically when they're doing things, you can actually make it so that they do not have access to do some of those things. And by the way, there's a ton of granular permissions in here for everything from event grid to deployment jobs to endpoints to everything. Let me see if I can find data. You could, for example, profiles and data. You can get whether someone can get an unregistered data set, can unregister. So basically, you can control people that can create data stores, artifacts, everything having to do with almost everything inside of these things you can control.
Nice.
So that takes me to the end of everything I wanted to show you. I showed you. Let's do a little recap here because I want to make sure that everyone's. And I got to turn this on again. How embarrassing. So okay, come on. There we go. Here, there we go. So basically, what we've done is we've gone through and we explained what is machine learning in the context of AI plus deep learning, right?
Yes.
We talked about models, right? And then I showed you how you can either use them. We did that with computer vision. Vision. We can modify them, and then we did that in custom vision, right? And then we did this cool thing where we built our own artisanal, free range model.
Yes.
So from scratch. And then we did that in Azure Machine Learning Service, right? And then we talked about this concept number 6 called ML Ops.
Yep.
And then the question that arose naturally, and we didn't plan it, but I knew it would come, is this question of control.
Security.
And what I did is I showed you the RBAC controls, which is what the identity show is all about, creating these things, RBAC controls for AML. And so that is the end of what I had to talk about. Any questions? I want to get back to the questions or thoughts or whatever you want, because I promised I'd stick to an hour.
No, it's fine. There was one question by our friend Bolt who said, what if you have a spelling error on your taco endpoint? will it be able to do fuzzy match logic, or will it fail to calculate the rating, for example?
That's a really good question. Remember, the thing is this is not magic. There's no magic here. And so if I go to this thing, what it will do is the embedding will map the text that it has in the vocabulary file to the appropriate vector.
Okay.
And that's it. Now, if you want to do fuzzy spell checking and all that, that's totally cool. But remember, this is an artisanal model that we've trained to only do a specific thing. This is not like, and this is the important thing. It's for some reason people think that machine learning does more than what you tell it to. It doesn't. It's dumb. It doesn't know anything other than what it was able to squeeze out of the data. And if your data is faulty, that's great. It won't work. If your input is faulty, that's great, but it kind of won't work either. But we can try it. Let's try it. I hate notice that it rated this as a 5. Right? Now let's go back.
Typos galore. I like it.
Let's spell it right.
Yep.
Right? Because this word, hate,
Yes.
it learned in the embeddings that this word is a strong indication. But, oops, I spelt it wrong. Oh, something went wrong. Oh, too many requests. I overloaded it. There you go. 5.
5. Okay.
But see, so no, it doesn't do more than what you tell it to do, ever. So you probably have to put some programming in there to spell check things and then pass it in.
Oh, I love it. That means by you saying that, that's a fantastic segue to my question. There is not going to be an AI revolution or the sentient being taking over humanity because our data sucks, more or less. So we have a long future ahead.
No, I mean, if you build them, like, here's the thing. The problem, it's an interesting question, right? The one thing I do not like is the anthropomorphization of these things.
Yep.
Because what it does is it shifts the ethics over there. It's like the machine learning model did this. No, it didn't. The data that it used told it to do that. And so we can't ever do that. So there is a way, like, you can build a bunch of machine learning models, like in a self-driving car. There's a bunch of models all over the place with sensors, with everything. You can make things do some pretty cool stuff with a bunch of models. And if you, for example, were to say, hey, we need to build a bunch of models to help with the protection of American citizens, for example, you can imagine a scenario where the model might learn we should just lock all of them up. Right? And that's bad. And so, but these things would never think on their own. They'll only look at data, and they basically optimize. If it needs to go through a garbage dump, it will optimize the heck out of things using basic calculus. Well, not basic, multivariable differential calculus, which sounds really complicated, but it's not. It's just vector calculus. And anyone's ever done calculus, that stuff's not even hard either. It's just a rate of change. Everyone does calculus when they're driving. Otherwise, everyone would be crashing. You just don't think of it as calculus.
Math is everywhere, but at the same time, explicitly saying it's math turns some people away, which is fantastic that you say we do calculus every day, all day, when we drive or when we do other things. It's just a case of us not realizing it.
How do you know, like, when you're at a stop sign and the other person doesn't have a stop sign, how do you know you have enough time to go before they hit you? Calculus. Your brain is good at it without thinking about it.
There you
It's
go.
all calculus.
Everybody can do it then. Everybody has the capacity to do some machine learning.
It's true.
Seth, I love the session. We learned so much. We had some fantastic questions. I really appreciate you coming with us today. We'll probably get you at some point in the future again when there are new stuff to talk about. But in the meantime, thank you very much.
Awesome. Well, thanks for having me.
Let's raid somebody else today. I think we're going to raid our friends at Coded Live. And then we will see. Oh, you know what? We have an impromptu stream today at around 6:30, or 6 o'clock. I'll kick it off myself. We might get JP to join us as well. We're getting some friends to raid us. And today, one of our friends, Learn with Leon, is doing an identity workshop. So if you want to join him, make sure to follow Learn with Leon. People are saying Seth is awesome. Awesome demo, Seth. They really appreciate you coming here.
Let's get some claps here for everybody. Thank you.
Yes.
Thank you.
Nice. Somebody got the AZ204. Congratulations, Bruce. That's awesome. Is that the machine learning one? I don't know. Which one's the 204?
I don't know.
Which one is it Bruce Lane? I have no idea.
I'm going to go to Twitch and see if I can read these comments here.
Yes. Oh, it's the Azure Developer Associate. Well, you know what? That's awesome. Good for you. I haven't done any exams in a while now. I need to get back into it. And there is a fantastic one for machine learning as well. We have a free academy. Is that right, Seth?
Yeah, there's a lot of training out there. There's a business one. There's some machine learning courses on MS Learn. You can get certified as well. But there you go. Everybody can count to 28 as babies. We get exactly 28 teeth.
That's perfect. Right. I'll put the links. I'll put the links down for all the training if you want to do it and get started with machine learning. And again, we'll say thanks to Seth and everybody. Have a lovely day. I'll see you this afternoon if you want to join me. Otherwise, tomorrow we have the IT Pro stream, and then on Friday we have another awesome stream. So stay tuned and have a lovely day. What?
And I have a show on Friday too called the AI Show where I'm literally building stuff. So come on. It's on Learn TV or on YouTube. Go to aka.ms/AI Show Live.
There you go. Seth has a dedicated machine learning show. Why not? Right. Thanks, everyone. Take care. We'll see you soon. And